Hey, what's going on? It's your old pal, Mr. Cook. We are through the second page and now into the third page from the review. So it looks like we got Venn diagrams. This is going to coincide with the 2.3 stuff, it looks like. Yeah, and then the next page is also going to be about 2.3. Okay, so 2.3 is about Venn diagrams and then putting them together, but then also reading information from them. It's about these like this other set logic and set notation where you're using these things called unions, which means like all the stuff together, and then intersections, which means like where things overlap, and finally like this little hash mark right here, which means the complement, where everything outside of that set. So let's put this stuff together. So complete the Venn diagram using the following sets, then use it to list the set of elements in roster form. So we just got to list off all the stuff that these different problems are asking us about. Okay, so let's put together the Venn diagram first. So what I like to do to start off a Venn diagram is figure out what's going on like in the middle of these things. So I'm going to label one of these little circles because one of these circles represents like the set A, and one of these circles represent the other set B. And then the set U is what we call the universal set, which represents like all the numbers that are in like this whole entire rectangle over here, okay? So the numbers that are in A and the numbers that are in B, all the numbers that are in A are going to be like in this circle. All the numbers in B are going to be in this one right over here. And some of them are going to be in both, okay? So I think like to make sense of this, it helps to color code it. So I'm going to say that all the numbers that are in A are going to be in red, and all the numbers that are going to be in B are going to be in blue, okay? But you notice something maybe right off the bat. We have some numbers that are in common with them that are both red and blue. So like the number 4, for example, is both in set A and set B. Same thing with the number 5. So those numbers that are in common between those two sets, they're going to go like in this region right over here. This green region is shared with both, the red numbers from A, and then also the blue numbers from B. Okay, so I've got this like green area where they're just in common right over here. Okay, so the shared numbers that I have in green, I'm going to put those in. So that's going to be number 4 and number 5. So number 4 and the number 5 both go in that shared region. Notice that 4 and 5 are both in the red, and they're also in the blue regions, right? They're kind of like in that green one, which is shared between them. That place where they're in between, that's what we call the intersection or the overlap between them. Okay, now there's the numbers 1, 2, and 3, and those are only going to be in A. So 1 and 2 and 3, and they're not in any of the blue regions, that they'd share. And then on the other hand, 6 and 7 and 8 are only going to be like over here. They're in the blue region, but they're not in that little shared green area between the two. Okay. And then, we look at the numbers that we have. So we have 1 and 2 and 3 and 4. See 1 and 2 and 3 and 4 all present so far. And 5 and 6 and 7 and 8. So that means that all of those numbers are accounted for in either the red region or the blue region. There is nothing outside of that. But if they did add another number like 9, for example, that's not in these groups, I'd put 9 like outside of both of those circles in the rectangle. Okay, but we don't have that, so we're not going to worry about it. Maybe we'll see that in another problem soon. So now let's start answering some of these questions. Now, it's really important for you to be able to read the notation that's going on here. So if you've looked at the 2.3 day 1 homework problems, we did this a bunch of times. You can look at the notes to kind of back reference it. But you learn to read the notation, and if you can read the notation after you put together a Venn diagram, it's like really, really easy. What this one says, in words is it's the stuff in A or the stuff in B. So what I do is I take the stuff in A and the stuff in B and I put them together in one set. That's what this is really asking you to do, and that's what that notation here means, that little U, union, represents. So if I take all the stuff in A, so that's like all the stuff in here, all the red stuff, I've got 1 and 2 and 3 and 4 and 5. So I'd include that in my set that I'm putting together in roster form. 1, 2, 3, 4, and 5. but I also have to have the stuff that's in B. So that B would be 4 and 5 and 6 and 7 and 8. But I already have 4 and 5 in there, so I just include the ones that I don't have yet, 6 and 7 and 8. So that would be my complete set right there for letter A, okay? So it would just be this set right here. But like I said before, it's like really important that you can read the notation in it. That's what can help you to get these answers done really easily. Letter B says A, and then like this little symbol here, which means intersection B. So A intersection B means it's the stuff that is shared or in common by both A and B. So what stuff do they both have? It looks like that's this little overlap area. So 4 and 5 are the ones that they have in common, that they share. So I'd only put two numbers down, 4 and 5 for that one. And that's my answer for this one. So intersection, when you see that symbol, that means in common. What stuff, where do they overlap? What do they have in common? C tells you the last one that you're really going to need to know. This little hash mark there, that means complement, okay? So A complement. So complement, like what it means in general is it's all the stuff that's not in A. So all of U, the universal set that is not in A, okay? So here's how I'd figure that out. So I'd start with U. So I always start with the universal set when I have to do a complement. And what I do is I take away whatever I'm taking the complement of. So I take away the stuff that's in A. So all the stuff in A is like here. It's 1, 2, 3, 4, 5. So I take all those out. 1, 2, 3, 4, 5. That's all the stuff that's in A. So A complement is going to be what's left over. So it's going to be 6 and 7 and 8. So the answer for C is going to be 6 and 7 and 8, like that. Okay? All right. Next up, we get to letter D. So letter D says, in parentheses, A intersection B, and then it has that little hash mark meaning complement. So you have to use your order of operations first. So I'm going to give you some advice, all right? When you see parentheses like this, do the parentheses first. Okay? Always do that. Always do the parentheses first. Like whatever's in parentheses, do that very first. So that's what I'm going to do. I'm going to do A intersection B. But wait a minute. I just found out what A intersection B is. It's that, right? It's just 4 and 5. So what this is saying is that it wants the complement of just 4 and 5. Okay? So I go over my universal set just like before. And if A intersection B is just 4 and 5, that's A intersection B right there, then that means that all the other stuff, 1, 2, 3, 6, 7, 8, that's going to be the complement of A intersection B. So those are the ones that I'm going to write down. I write down all those numbers, 1, 2, 3, 6, 7, and 8. And that's going to be the complement. And that would be the answer for letter D. Similarly, if I looked at, at letter E, I notice that there's something in the parentheses, and I've got to do the parentheses part first, right? So let's figure out what that is. So A union B. Wait, I already did that, didn't I, in part A? So it's all these numbers, 1 through 8, basically. So now I got to do the complement of that. So I go over to my universal set because I got to start at the universal set and I do the complement. And I'm going to take away all of these ones. Okay, so 1, 2, 3, 4, 5, 6, 7, and 8. Well, that's everything. So since that's everything that was eliminated, okay, so if all of this stuff is A union B, then that means that the complement of it doesn't have anything in it whatsoever. So we call that the empty set. So you can write that a couple different ways. If nothing's left over, you can put a little circle with a line through it, or you can write it up like this, just like the little squiggly brackets, but there's nothing inside of it. Okay, the last one is going to be F. So F means B complement. So we start at the universal set because that's what we do with complements. And then we take away B, all the stuff that's in B. So all the stuff in B is here. It's going to be 4, 5, 6, 7, and 8. So that's all of B. So B complements whatever is left over. So it's just going to be these things, 1, 2, and 3. So 1, 2, and 3 are the ones that we put there. Okay, so that's number 23. Just going over the simple set notation and just learning how to use these operators, the and in the or case, and then also complement. All right, next up, 24. So 24 and 25 use set operations to answer these questions. So U.S. workers were asked whether they preferred to work from home, I think so it was from home, or go into the office. 150 workers said that they preferred to work from home. 85 said that they preferred to go into the office, and 39 said that they like to do both. So how many workers preferred each? So what you would do is you would just make one of those little Venn diagrams, and then you'd have people that like to work from home. So let's say that that's H, and then the ones that like to work from the office, that's O. You make a little rectangle around it to represent people that didn't want, work either of those. I mean, that's like the whole rest of the population, right? That just doesn't want to work in general. Anyways, so if it says like that 150 workers say they like to work from home, so 150 total are going to be in this like H circle. Let's color code it. Okay, so that's going to be the red people, 150 that are going to be working from home. And then we have blue. Let's have blue represent the 85 people that want to work from the office. Okay, so 85 people are going to be in like this region right over here. And then that's total, by the way. And then 39 people, we'll do this one in green, say they want to do both. If it's both, that's like in this region right over here, okay? So 39 people go in the middle. And remember in the Venn diagram, it's a really good idea to do the middle part first, because then the rest of it just kind of gets really easy from there. So if I know that 39 people want to do both, then those 39 people eat into like this total of 150 people. So 39 of them, right, count, from that 150. So the way that I'd find like the number that goes in here is I would take 150 and I'd subtract away 39, because 39 of those people in here are already counted right over here. So I take that away to figure out the number that's like kind of left out of that shared region. So 150 minus 39 is going to be 111. So 111. And then same thing for the blue one. So since the blue one has 85 total people like in it, then 39 of them are already counted in the middle over here. So what I would do is I'd take 85 and I'd subtract away 39, and that would give me the total. So that'd be, I think, 46. So 46 people would be over here. And what this means is like 111 people only like to work from home. 46 people only like to work in the office, and 39 people like to either work from home, so it counts, among that 150, or they like to work in the office. They don't really care, so they count for that 85 as well. So now it says, to follow. All right, so now we've got all the information. We know like how all those people are split up, and how many workers prefer to work from home or go to the office. So that "or" word means that it's going to be the union. So it's going to be the people that work from home or they work from the office, and it's going to be the union between them. I shouldn't write the letter U. It's not quite the same. But that means that what is it all together? So what we do is we take all three of these numbers that we have listed when we want to do the union, and we just add them together. So the number of people that either like to work from home or work at the office, it's going to be 111 plus 39 plus 46. So if you add those up on your calculator, that's 150, 196. So 196 people. And that would be my answer. And again, this would be a multiple choice question. You would just have to get to that conclusion and then, see if the answer is there. Okay, one last problem from this page, number 25. Seniors at Corona del Sol were asked if they like to stay on campus or leave campus for lunch. So those are our two options: stay on campus or leave campus. So let's say stay. So that's S, and then leave L. Okay. So 85 people said they like to stay on campus. Okay, so it looks like it's going to be a similar setup as the previous one, where we have people that want to stay on campus and people that want to leave campus. Okay, and same situation. Let's say that let's use red for the 85 people that say they want to stay on campus. That's going to be this group right over here, 85 total people. And then 104 people said they like to leave campus. So let's make that one blue. 104 like to leave campus. So that's this group over here. We always want to start in the middle if we can find that information, and that's what the next part of it says. 28 people said that they like to do both. So 28 goes in the middle right over there. And then we, take that 28 and that eats into the total for the other ones. So let's figure out what goes in those other numbers. So 85 total is going to be in the red area, but from that we're going to subtract away 28. So 85 minus the shared amount, 28, That'd be 57. So 57 goes over here. And then the number of people that would leave, that's going to be 104. And similarly, we're going to subtract away 28 from that. So I think that'd be, 76. Yeah, 76. So 76 people are going to go right there. Okay, so just subtract them. All right, and then now I didn't really say this in number 24, but if it also said that, like, if it told you how many people were surveyed, let's say that there were, I don't know, like 300 or something, what we would do to figure out like the number of people that didn't really care, or well, that like didn't like eating on campus or leaving, which I guess would be like nobody, because I don't think there's a third option. Like that total would go like in this little box area, which would represent people that don't fit into either category. Okay, so just be aware of that. That sometimes happens too. All right, now let's answer the question. How many seniors said they like to stay on campus or leave? So this is going to be stay on campus or leave. So it's going to be like that union. So just like before, what we're going to do to figure this out is we're going to add all three of these numbers together. So 57 and 28 and 76. Gosh, excuse me. All right, so let's see. That's 85 and 76. What is that? 161. Oh, I better use my calculator for this one. I can't do the mental math on that one. So let's see. 57 and 28 and 76. It's 161. Okay, so it's 161 people or students, whatever, seniors. Okay, there we go. So that's number 25. All right, that completes the third page. So then we'll go to the fourth page on the next video, and so on. Okay, well, I hope you found this one helpful. If you didn't, then go find your math teacher, get some help from them. I'm Mr. Cook. If you need help from me, I'm on campus before school and after school. Just try and track me down, and I'm always willing to help out. All right, thank you very much for watching this video. I hope you enjoyed it, and I hope to see you in the next one. Bye-bye.